right. Are we ready? Just to confirm that it's going to be. Can we bring this thing? Yeah, so it works. Okay, cool. It's lots of stuff to cover. So initially, I was thinking to talk about one thing, but it turns out I really want to talk about 5 things, or even like 6 different things. So that's why I call this 5K. We're going to be talking about Kotlin. Give me just an idea. What's the breakdown? Developers, operators, developers. Okay, good stuff. My favorite people. Operators, DevOps people, few people, cool. Any Scala developers in the room? Okay, right. Okay, they try to learn something from the Kotlin. Do you know what's the difference between Kotlin and Scala developer? Like, if you're Java developer or any developer, you can easily read Kotlin code. Whereas the Scala developer, you cannot even easily read your own code after a certain time. So that was obligatory joke for Scala folks. Yeah, so it's going to be cover a lot of things. It's going to be very like a fast-paced thing. Very advanced thing. I'm not going to go in details of architecture of Kafka, architecture of Kubernetes. Hopefully you know these things. If it would be like 100% gibberish for you, just raise the hand and shout your question. I don't mind you interrupting me. If you have, it's better to answer the question within the context. Also, you can wait. Also, you can find me afterwards to answer these questions. Okay, so what is serverless? The most common question, most common answer that I'm getting is that actually it's someone else's computer, right? So it's someone else's computer that runs your workload. Well, maybe not. So today, hopefully after this talk, you will have the idea what does it mean your application to be serverless. And today I'm going to be talking on the concept of portable serverless, meaning that you can apply the skills if you're using managed service, or if you're not using managed service, you're using your own infrastructure and you're deploying open source tools like Kubernetes, Knative, Kafka, what else? The Kong operator, whatever. So this is applicable for both cloud systems and on-prem systems. So get ready. My name is Viktor Gamov. I work as a principal developer advocate at a company called Kong. All sorts of stuff around the gorillas and the cloud connectivity. Love Kubernetes, run all my workloads there. I also Confluent Community Catalyst and Java Champion. Also, I wrote the book about Kafka, so I know a few things about the stuff that I'm talking about. Yeah, it's from different presentations, sorry. Yes, if you're interested in Kafka, this book is available, 35% code on the Manning website. It's probably a good book. All right, also I build highly scalable and highly available Hello World application. Today is going to be a super highly scalable, super highly available application. You will see of the level of complexity of this application. Maybe you don't need to have during, let's do a good, nice, okay. So, what actually is serverless and what we're going to be talking about. So serverless, it's actually a model how you operate your software. And essentially, it's a model that is somehow related to costs of using your software in the cloud. In the past, most important numbers for developers, they were number of, haven't you seen this? The most important numbers that developers need to know, and it is numbers how the latency grows from the registers of CPU to memory, and how latency grows from the memory to disk to network and things like that. These days, most important numbers that developers need to know, how much does it cost? It's a bad thing to say, if you want to run something faster, just swipe the credit card to get bigger instance, right? It doesn't mean we don't need to thinking about optimization and don't think about our quality of our code. It still matters that we still can solve some of the problem with money. We throw in more money, running more stuff there. Now, serverless, it's the demand-driven model of dealing with the workloads. So let's do this one more time. Yes, so first of all, 12-factor applications, right? So your applications needs to be kind of not aware about infrastructure. They don't need to stick to particular host names and particular file systems and things like that. Your applications needs to be portable and serverless. So in this case, you will rely on a lot of infrastructure, like different discovery services. You will be relying on the way how the provisioning will be provisioning your application. So more information on 12-factor app. The Heroku people pioneered this idea. So every time when you do like a Heroku push with your application, how many of you done this type of approach? How many of you played with Heroku? Few people. So idea of Heroku is that you have your application source code and you have a Heroku command, and the rest of the stuff the platform will take care of you. They will build your application, they will deploy your application, they will provision the resources for your application. And the only thing that you need to keep in mind for this is how much you will pay. For a very long time, Heroku was free. Now they introduced some of the pay tiers. But idea of having this kind of like on-demand deployment of your applications without you thinking about how I will provision this. This was very, very appealing for many systems. So one of the systems that we'll be talking about, the Knative, is borrowed a lot of ideas and brought them into Kubernetes world. In the cloud world, what does it mean serverless? Essentially, it's what you're paying for using software. If you're not using software, if you're not using infrastructure, you're not paying for this. And in many systems, you can pay for this type of things. You know, ingress, how much traffic you're paying for traffic if traffic goes in, how much you're paying for traffic goes out. In some of the systems, you're paying for storage, how long you store this, or for time. Like there's a retention, different SLAs for the systems. For tools like Kafka and Serverless, Kafka in Confluent Cloud, for example, you're paying not for storage in gigabytes, you're paying per partition. So you can have a different granularity options for your systems. What does it mean to be serverless in your own on-prem environment is to efficiently use resources. So if you're not using some of the resources, your application is not running. Why to like burn these cycles? We just remove this application from running. It will be available and it will be spin up next time when the request comes in. And after that, if no one is using the application, it will go down. So the Knative allows to do this, type of things. Now, with the portable, what I mean by portable serverless, you should be able to, using the open source tools and the modern infrastructure tools, you should be able to move quickly between different systems. So you start on your local laptop, computer, your CI system, and you will using tools like test containers to so I'm not a huge fan of mocking as a concept, because mock will give you only maybe faster unit tests. But if you want to do some of the local integration tests, test containers and the testing in general against real software, it is much better than testing against mocks. We can talk about speed and execution, how tests can be execution faster or slower. But in general, this is kind of like, this is where you start. As a developer, you start writing your code. You're developing tests against the real software, including containers. Next step is that it works on your infrastructure. You bring in this infrastructure, you have your own SRE team that manages Kubernetes cluster for you, and you bring in there Kubernetes, you can bring Knative, some other tools. Very popular model of managing software inside Kubernetes cluster is the operator model. We're going to be using operator for Kafka today. So this operator will be managing our Kafka cluster, and we don't have to. And the third thing is that you're working on the managing services. So with the portable tools and portable infrastructures, you should be able to navigate and you should be able to migrate between those different layers. You can start easily writing your applications and using test containers for testing those. You go, if you have your own infrastructure, you're running this. Or if you decide, okay, so I will just rather pay for some of the systems, I will pay for Google Cloud Run, which is managed service or managed version of Knative, or Confluent Cloud, which is managed Kafka. All right, so one of the tools that we're going to be seeing today. Yep. So, and we're gonna talk, since I will be using the Google Cloud, I will be using Google Cloud to provision my Kubernetes cluster. Kube control, how many of you agree with my pronunciation of kube control? How many of you call it kubectl? kubectl? Kube control? Few of my people here. What's other? Kubectl? No? It's a long discussion. So we're going to be using Knative, going to be using StreamZ for Kafka, and we're using Spring Boot and Kotlin for our business logic. All right, so let's see some code in action. This is going to be exciting because it's very complex application. So that's why I draw the diagram. So that's the diagram of my application. Everything that I will be showing today will be running in someone else's computer in Google Cloud. I'm using Google Cloud just simply because I get to like their tools. I'm not get paid by Google Cloud. It's just like to use their tools and running theirs. So for the Google Cloud, I'm using this also community tool called GCP Ping that shows me, based where I am right now, what would be the fastest accessible infrastructure. So since I'm in Europe and Warsaw data center is a closed one, so I provisioned my Google cluster, Kubernetes cluster in Google Cloud in this Europe Central 2. So we're gonna be using two applications. One application is a chat application, and this application allows us to sending messages from one window of application and receiving messages in another window of application. But it would be not the simple chat because you need to use something starting with the case. So we're going to be using Kafka to do this exchange of the messages. So message into chat in, and after that another window will be listening chat out. Once we will deploy this in Knative, we're going to be using this concept of Knative eventing, and we will integrate event-driven microservice with just a traditional REST API microservice. So this explicit filter, we're going to be invoking this and check if some of the messages will contain some explicit words, like a full bar or some other F words. Instead of writing this logic or orchestrating this logic somehow ourselves, we're going to be using the Knative eventing to define where the data come from, what would be our source, and what our sink, and we're going to be using cloud events to wrap our data and invoking this filter. Once I want to invoke the expose these microservices, and you will be able to, if you want, you will be able to also interact with this microservice yourself. We need to have an ingress object. And the ingress object is something that runs also inside of Kubernetes and provides external access to your applications from rest of the world. One of the reasons why I like to use clouds and things like that, so it allows me to have external IP address, externally addressable IP addresses. So this live demo would be really live. So on the ingress side of things, in order to maybe also prevent us to spending too much time on the API calls and the traffic on the egress side of things, we can implement some of the plugins around rate limiting. So that's why I'm using this Kong ingress controller, which based on the Kong API gateway. And I'll show you how we can change behavior of application without changing code of application. So that would be also interesting for operations people. So let's see what we have here. So first thing is that let's take a look. I slightly over provisioned, so I have 15 nodes inside my cluster. It should be relatively big enough, so I run things like Kafka and stuff like that. Let's start with our chat application first. So this chat application is a Spring Boot application. I use Kotlin in Spring Boot, and let's see if we can run this. So we just do resolve boot run. Boot run. And what does it say? It's not running. Why? Because it is require a Docker that is not running on my computer. And the reason why I need to Docker, because during the startup of this application, I also spin up the Kafka because I'm doing local development. I want to spin up a Kafka server before I start using this. So for this, let's see if I have Docker up. Okay, Docker is up now, so I can do this one more time. All right, so one of the things you can see from here, let me do this a little bit bigger. I start my application, and all of a sudden I have a container that runs Kafka server. So I'm not starting this manually. I'm not using Docker Compose. It's running as a part of my application. And the way how it works, I can provide the application initializer for my Spring Boot application, and before application will start, it actually invokes some of the test containers API. So the way how it would look like for my local development, that's the super nice UI here. And as you can see, I'm following engineering design type of thing, so it's very super simple. And let's see, we're gonna bring another window. Come on, another window. In a 3, 2, 1. Looks like my browser stuck. That's the beauty of live demos. Here we go. Okay. Yep. Okay, chat application. This is the test. This is the foo, bar, the buzz, blah. So you got the idea, right? So those things are talking to each other through the WebSocket. If I will show you here, for example, this is chat application. The message is coming in. So if I will just go and say test, I get some messages from here. So the way how it works, there's two components that in this application. One is the listener that would be using Kafka consumer to listen messages from Kafka. And another is a producer that sends message to Kafka. So that's the local development. This is how you're iterating. You start your application. You're writing your test against this infrastructure. This all works, and it's nice and fun. So the next thing is that let's bring this application to my Kubernetes cluster. And the way how this will working, we're going to be using Knative. Knative is a open source project that allows you to follow very similar ideas that were developed in Heroku back in the day. So just push your application, and you don't need to worry about creating your. I hate when people saying this, you don't need to worry, and I'm saying this myself. So you can worry about this. However, the framework takes care of some of the things that you otherwise do manually. For example, it's not super difficult to do deploy any simple microservice to Kubernetes. You need to have deployment, you need to have a service. If you need to have external access, you need to configure ingress. There will be a pretty cool session later today about Decorate, which is another annotation processor for Java that allows you to generate many of those components out of your code automatically. But here we're following conventions. So we're creating a service in terms of not Kubernetes service, but Knative service. And rest of the stuff would be take care of the platform. So deployment will be created. There will be created all networks. There will be created ingress for your application. More importantly, the platform also will be take care of spinning up actual application if you need this. So we will see that if we not be hitting this chat application and loading this UI, this application will not be deployed and it will not be running. There will be one small stop that will be running there, and whenever we need this application, Knative will bring this up. This is real idea of the serverless microservice deployment. So with this, for example, my chat application already has Docker image deployed, and before I deploy chat, let me show you first how this thing would look like in the very beginning. So by default, Knative provides this demo application that only thing that I need to specify here is image of my application. And the rest of the stuff will be taken care of the platform. So I will go ahead and create this service. So this service was created, and if I will show you some of the bits of namespace, and I'll show all service, serverless service. Oop. We're going back to namespace, all namespaces, serverless service. So it created the serverless service here that will contain multiple interesting things. And one of the things that we see here, it's not even running because no one actually requested this application. So if I will go and open a public URL for this application, should be somewhere here. Let me do this manually in this case. So I'll just do get serverless services. And that's the external access. So this is the address that the application is available. This is the external address of my load balancer. And I'm using this small service SSL IP. Let me put this one on. So in this case, if I'll go ahead. So what will happen the first time? See, right now it's loading. It's not because I have something wrong in my system or internet is slow. It is first time I'm hitting this service. It's actually spinning resources for this application, and based on things what we can see here, it should be say ready or something like that. Let's see. So it's ready, it's true, and we have something like hello world response. So after certain time, like a few, maybe around a minute, if I will not do anything with this application, Knative will be take care of and shut this application down. So next time, URL still will be available, ingress will be available. And the way how it's done, it creates this sidecar container for my application. Let me see, deployment. And for my Hello World deployment, it will include two containers. One container is user container. This is actual application that will be receiving a request. And there's a proxy sidecar container that will be sitting there and waiting for requests. So one of the things that I also can do in this application, for example, since all the traffic goes from my Kong ingress controller, I can enable certain plugins. So let's have one plugin that will be just injecting some random header here, and another plugin that allows me to limit number of requests to this application. So serving your resources can be done through internally using the runtime, and that runtime will be responsible for taking care of resources, plus externally using the API gateway side of things. So if I go ahead and apply those plugins created, and in order to the service to pick up all this configuration, I need to provide a metadata that would be added to this service template. So in this case, one of the things you can notice here, see, I didn't touch this application for quite some time. I was talking, and now it was undeployed. It was undeployed, and it's not available here. So now when I will hit this URL one more time, it will refresh and get the response back. And if I'll show you, and now we have deployment back. So this is how the platform allows you to save some of the resources. And now I need to redeploy this service, update this service, and we will be able to see something like, if I will do this. One of the things that you can see here, some of the headers were injected here, so looks like a live demo works. That's awesome. Let's add a rate limiting as well. So the way how it works, I will add here rate limit. That's the name of the plugin. I need to annotate the service and update the service. Should redeploy this in a few seconds. So in a few seconds now, I start getting the plugin is works. So if I will continue to hit this, 2 remaining. Come on, come on. Remaining per minute. 2, 1, 4. But you got the idea. Eventually, it will also will tell me that that would be limit. The limit would be exceeded. So that's the basic deployment of microservice. So now let's deploy our chat application. So our chat application will be this is how it looks like in the service. It will be using my image that is deployed in Docker Hub, but also this guy using the Bootstrap server. The way how the Kafka server works, in order to system to communicate, it need to expose the Bootstrap URL, and from this Bootstrap URL, the systems will be discovering other tools. Before I deploy the service, I need to deploy my Kafka. So I go into Kafka, and for my Kafka, this is how my deployment look like. So I will be using Streamz, which is open source operator for Apache Kafka. And the idea of operator is that you're not also talking about services, storages, and all these kind of things. You want to deploy a Kafka cluster. And operator is kind of provides you DSL that will be only related to this, the Kafka thing. So for example, I'm here only providing configuration for how many nodes I want to run here, or what's going to be topics configuration for my Kafka cluster, and all this type of jazz. So I'm not providing persistent volume claims here. I'm not providing services. I'm not providing headless services. How many of you actually try to run Kafka on Kubernetes just like from get-go? Okay, a few people. How many enjoyed this? Okay, a few people enjoy this. I am the one who enjoyed doing this in the past, but for the live demos, it's just like too boring. This actually creates the wow effect when you're creating this. So basically, what I need to do is Kubernetes control apply. I'll just do Kafka, and I deploy my Kafka cluster. So cluster is created. The way how it looks like from perspective of Kubernetes resources, now what I can see here is my cluster that has like desired number of nodes, but right now there's nothing is ready. Why is that? So Kafka, at least until recently, and still depends on some other things. It depends on Zookeeper to store some of the metadata, and as you remember in my configuration file, I didn't mention anything about Zookeeper. However, operator knows that it's an important thing to have. So that's why when I go into, you know what, I just messed up a little bit. So just give me a quick second. We will just do this. We will delete this. We will delete this. And after that, I will deploy in namespace Kafka. So in this case, it will be correctly created in correct namespace. Oops. Oops. So in a Kafka namespace. Okay. So now what this will do, it provision first Zookeeper, wait until Zookeeper will be ready. Next thing, that this operator will continue to monitor this Zookeeper thing. It will provide a, when Zookeeper will be available, usually through Zookeeper provides the command line that interacts with it, and you can send some special commands like you're okay or not. So Zookeeper is up. Now Zookeeper is up, and I'm bringing my Kafka cluster container here. Looks it's running. Let's see. It's getting there. It's getting there. The only thing that I did is just installed operator before. Essentially, it's just a few CRDs that I need to install my Kubernetes cluster. And now I can operate with my Kafka cluster. So it's getting there. And also, if I want to provision topics, if I want to provision users and creating RBAC rules, Streamz takes care of creating all these things. There's a user operator, there is a topic operator, all these kind of things. We're not going to touch this in this session. So where's my chat applications? For the chat application, I can start deploying my service. So I'm gonna go and create it Kafka application. If I want to do, so now I have two services. Remember, one service is Hello World. Now my chat Kafka service is deployed. So let's open this in the browser, and it starts quite relatively fast. Let's see. Let's take a look on the user container. Spring Boot application is up, and I connected to this Kafka cluster from my Kubernetes, and now I should be able to start doing things. It should be test, and there's nothing is happening. Hello. Why is that? So there's two systems that you saw previously, like when I run this locally. They use different configurations. So essentially, in one component, in one application, I have a consumer and producer, still have the same type of functionality here. However, in this type of configuration, my Kafka output is not, the new messages are not provided in this topic. So all the messages only going into Kafka in. So if, or chat in message. If I will go and use something like Kafka console consumer, and I will read from topic chat in. So in this case, I'm running this Kafka console consumer tools from the containers. So all these messages that I have previously, Kafka is persistent system. So if I will go and do hello, Infoshare, and the message is still here. So message arrived in the Kafka topic. We're good. So this part of application is worked. However, if I will do stuff like a foo, bar, buzz, and stuff like that. So, and I also don't receive any responses here. So the messages are going here. So next thing is that, yay, my people in the room. Some hackers that hacking my URLs. Love it. I love it. That's why I love to do live presentations. Now, so next thing is going to be very interesting. So another microservice that I have is a simple microservice that have a REST endpoint. Through this REST endpoint, I need to submit a cloud event. What's a cloud event? It's the specification that allows you to define platform-independent encoding of your message that can be shared between different systems, and those systems don't necessarily need to know about serialization and all this type of jazz. For example, if you use Java serialization, so probably you're stuck with Java, and no other systems will be able to decode this message. So for that matters, you're probably using Protobuf or Avro or Drift or some of those variation of the cross-platform serialization formats. The cool thing about cloud events is actually JSON. So it's JSON with some extra fields, some extra metadata, and you can read this. And the format for this metadata is relatively simple. So we need to provide some of the ID. We need to provide a kind of source. We're going to be using this, and the Knative uses this stuff in order to identify where the messages are coming from. Now, doing this really quickly. So next thing is that we need to wire all these things together. So we need to enable this the Knative eventing in order to create this connection between our chat application, Kafka, explicit filters, and output to these to this topic. So Knative eventing allows you to abstract from the transport. So it has a concept of broker that can be Kafka broker, can be Redis broker, some other bindings available. So let's start by creating this one. Next thing that for my Kafka, I'm creating this Kafka source. It's also object part of Knative eventing that allows me to reading this system, this eventing, this the serverless component that will be do routing, will be reading from this topic chat in, and it will be discover this through the broker. Creating this. Next thing is that once message arrived into this topic, we want to trigger something. So in this particular case, for the message that we received, we want to trigger transformation. So in this case, we're going to call for explicit filter. This is our service that we're going to be calling. And this is a reference to the service we're specifying here. Service, Knative, and dev. In this case, the Knative eventing would know how to discover the service. So it also does service discovery. Once we're done with this transformation, we get the post request to this filter message, and we get the response back with filter message. And now we need to push it back to output topic, where our Kafka consumer will be reading this. And as a result, we will be providing the actual sync, what was going to be stored inside this message. So as this is deployed, explicit filter. Another thing that you also can deploy services that not necessarily needs to be exposed to outside world. So in this particular case, my explicit filter will be used internally by eventing system. So in this case, I'm saying the cluster local. So ingress for this for this service will not be created. So I don't need to have ingress for this. So, oh look, wait. I don't wanna spoil surprise. Okay, okay, delete it, and now we're creating this one. Okay. Now hopefully, let's copy this one. Everything should work. And here we also refresh, and let's do test. And nothing is happening. Nothing is happening. Actually, it's happening. So underneath this service, explicit filter service will be provided for the first time. And after that, the eventing system will invoke the service. And after that, we will see the result in the Kafka topic fairly soon. And this is what we see in the messages. Let's see, foo. Message still works. Let's see if my service with okay, hello world created. I actually need to have no service dot no, where's the Knative service? Let's refresh it one more time. Let's see if this will fix that. Oh, I know what. I just need to check the deployment for explicit filter. Let's see. Default explicit filter terminating. Why is that? Let's see, user container. So it's up and running. It should work. Let's see, container creating. So this is where it's redeploying. Real-time systems are so real-time. Okay, now works. Whoa, okay, so round of applause. I have a few more seconds to show you one cool thing. It's slow because this application written in Java, and the haters will say, it's Java, it always will be slow. Not anymore, because with this, yay, it works. Okay, but also check this out. Foo, bar, buzz, whatever, right? So it works. One last thing. In my, I actually have a, let me show you quickly, where our explicit filter, user container, and the startup time is 5 seconds. Well, I mean, your grandfather say, yeah, I never seen the Java application starts in 5 seconds because, you know, during their times, the application started in like minutes or whatnot, or hours if it's a WebSphere. But with this new exciting things from Graal, we can build a native image. So, and I will deploy this, and this application will be rolled. So this filter thing, yay. Let's see if it works. If it works, now where is it? Where's new version? New version. And behold, that's the start type of your Spring Boot application. 66, I don't even know how to pronounce it, but milliseconds or whatnot, like 6 milliseconds. I think it's pretty impressive, right? So with this, many of you might think it's too early for you. That's okay, but your kid's gonna love this. This is how we're gonna be deploying our software in the future. With this, my name is Viktor Gamov, and as always, have a nice day.